All right, so today we're going to be looking at our newest demo of Beta AI, where we demonstrate its ability to integrate with a variety of different applications and submodels on the fly. So currently, Beta AI has ability to effectively act as like an AI front end to applications on the back end, and now it can interface with submodels. AI models, so language large models, as well as submodels within Beta AI. So Beta AI is a hybrid model between language model and a state machine. And the advantage that gives you is effectively ability to constrain its behavior to only do things that it's supposed to do. So to properly integrate Beta AI with another application, in addition to like the traditional regular prompt-based training data you give it, you can also give it triggers to integrate with the prompts that tell it what to do when a given prompt or input text is taken in. So in this case, we're looking at an example set of applications. So one is a video generation application. Another is a checkers application. Another one is a tic-tac-toe application. So if we go in here and like get the application started, so we say like, okay, we just want to start, working with the video application. So we say, start or create me a video. A video for me. So now we go, submit, and it's going to say, okay, is went in, and the application says, I can't create a video because I don't have enough information. So what I need is a title, subject, and link for the video, and optionally an organization to run it under. And this is because there's another application running on a server that does this and it needs this information. So it can say, okay, this example user is a bit temperamental. They can go off and do that. But let's say, like they say, I want to go, start a game of checkers. So we say. So you do that, and so this integrates, triggers a submodel, and our submodel can then say, okay, I can create a checkers board. And if you notice, this is wrong, and I noticed this right before I was going to create the video. I was like, oh, in a separate demo, I changed the checkers board layout. Let me go fix that model right here. Fix the model. Let's go do that again. Start a game of checkers. And boom, it just fixed it. Now that's a proper checkers board. And R is for red pieces, B is for black pieces on a little, very simple primitive board. The AI, there's an AI model for rendering the board. There's an AI model for playing the game. And then there's an AI model for listing out the moves that a player can take at a given point in time. So it's actually like three models running at once. And this is interesting because you can't do this with the traditional LLM where you just say, "Hey, you did something wrong. Here, fix it," and now it's automatically fixed. And if I say start a game of checkers 10 times, it's going to create the board correctly 10 times. And we can even say say choose a move, and it's going to go and play for red first, and we can see red pieces moved up here from down here. We can do this again, make a checkers move. Or choose a checkers move. Go do that again, and it's going to go, move a black piece, and so on and so forth. And the model hasn't been fully trained on like all the rules of checkers, so it's going to kind of play it like chess. So it's going to try to move the red piece into the black piece. But that's just I haven't finished the training because this is just a demo. But the cool thing is like the AI model is playing the game. It's also running all of the rules through the AI itself. It's not a separate piece of software. It's also choosing the moves. So an AI move is saying like, hey, these are the moves that you can list at this given point in time. And this is an AI model that's doing on the fly. And another AI model is saying, okay, given this list of moves, what's the best one to take? And the best one to take in this given position, like the normal position, just chooses a move. Semi at random is going to always pick like the simplest move. But this one's going to say, okay, well, the best move I can take is actually right here. So if we do this one last time, you can see it's going to move. It doesn't jump over, but that's just incomplete training data. Now if we go and say we want to go and do like say play a game of tic-tac-toe, it's going to, now this is just going to simply like play a whole game with itself. So you say, okay, we got player one, and it's going to, moves up here. Player two is going to go over here. Player three is going to go here. And I want to show it's actually like the AI is using its own generated strategy. It generates a strategy on the fly. So, player two goes here, player one goes back here, and then player two is going to be like, hey, player one's going to win if I do that. So it knows this, it understands like basic strategy, and it derives this on the fly for itself. It's not done through training. So the only training I gave it was how to define the rules, and then it says the AI says Beta AI says like, okay, how do I define like basic strategies? And I'm working on algorithms that can say, okay, part of like the winner tree algorithm is saying how do you derive this, so it can figure out like how to fix things on the fly, because you put the software in front of users, they're going to give the AI situations it's never seen before, and the AI needs to figure out how to do it itself, even if it doesn't have the prerequisite training to do so. You can see actually player two got a fork, and then player one's going to just go pick a place at random because it knows it can't win, and then player two's going to win. And it's not the same game every time. So if we say play game of tic-tac-toe again, it's going to go and think, and then it's going to choose a different move. So before X went on the top, now it's X is at the bottom, and it'll keep playing until it's a tie. But then I would say, okay, here's the cool thing. So one of the issues with current AI technologies is they use context windows, and context windows is like the current technologies with LLMs are that they tend to forget a lot or misremember, especially stuff that's in the middle of the context window. I think there's like a special problem. But watch this. We don't have this problem. So our AI, once it gets information, it will try to serialize it to a database and then retrieve it later. And an LLM to say, oh, we've got a model that has an 87% accuracy rate for remembering information, and then another one says, hey, we've updated it so that we've got a model that has 92, 93% accuracy. Well, we already have a technology that has a near 100% accuracy rating for returning data, excluding like network outage or cosmic rays, and that technology is called a database that we figured out half a century ago. So we say show the checkers board, and it's going to go off and pull that data right from the database and show us where we were right off. And it doesn't matter how much information you put in the middle, it's going to remember that data until a database shuts down. There's no context window. So if there's a million responses and then you say show the checkers board, it's going to show this. You cannot do this with other pure LLM technologies with context windows. Eventually it's going to forget. That's a guarantee. If you keep going too long, the context window is going to go kaput. And even if it's in the context window, there's no guarantee. And then we can say, go back to our video demonstration. Say, the video's title is playing games. And this is going back to something. So the next feature I'm working on is actually, this is intentionally blank, is getting the AI to proactively generate responses. So currently a lot of AI technologies are very reactive, use a sensor prompt, and that can get a response. And then you can actually, like the beta as it is, I can set it to train it to response. I intentionally set it blank here. So you can say beta, hey, if the user says this, then say this. What I want to do is say, okay, that's not how we really work. That's not how humans work. We say, okay, given a situation where I'm at, what's the best thing to do at this point in time? This is how beta is laid out, is saying, hey, well, what's the best thing to do is, proactively thinking, I haven't given a response yet. The best thing to do is send a response. And then what's the best response? Well, look at their workflow and figure out, okay, based on the workflow, what they're doing. And there is some computation behind the scenes, and I can show that back here. So I can look at my personal chat history. And I can show it's actually making these calculations where it's saying, okay, the highest priority things to ask for is like, okay, I'm talking about generating a video. That's my last response. Tell the user to ask for video length, and then you can add some training data saying, okay, when you see this trigger, this is how you should talk in natural language. Either send a pre-canned response or then send something to GPT to prim it up so it's not the same thing every time. It can also ask for a video subject. So that's what I'm doing, and I'm also working on a CRM based on this. So I see demos like, okay, we've got demos for games, very cool, but the practical things like, okay, how do you do this? Use this as a front end for your business. We talk about, trying to make sales, trying to, bring inboard, trying to maximize conversion rates for potential inbound leads, stuff like that. So that's where I am.